Hello folks, we are back to part 5 and it's our induction chapter. So let's continue with the problem number 9 now. The problem says it's 1 by 2 plus 1 by 4 plus 1 by 8 and so on till 1 by 2 raised to n. You have got to show that this is equal to 1 minus 1 by 2 raised to n. It's a very powerful result. It's used at several places elsewhere. So therefore this is the result and we have to prove this. So as usual we start with let Pn represent the given mathematical statement. Step 1, to show that P of 1 is true, that is the first term on the on this side and on this side replacing n by 1. Then we look at the LHS. LHS is half. We look at the RHS, 1 minus 1 by 2. So when we try to equalize it and find out 2 minus 1 by 2, that's 1 by 2, half. Otherwise also 1 minus half. With our common sense we know it's half. So that way we have got LHS to be equal to RHS and therefore P of 1 is true. Now assume that P of k is true. Now how to get P of k? You're going to write wherever n is coming, there we can replace k. 2 raised to k is 1 minus 1 by 2 raised to k, like that, k plus 1. What does that come to? It will come to 1, all these terms plus 1 by 2 raised to k, next term 2 raised to k plus 1, 1 minus 1 by 2 raised to k plus 1. That's how you get the result. Now, in order to show that P of k plus 1 is true, let's take the P of k plus 1 statement. It is 1 by 2 plus 1 by 4 plus 1 by 8 and so on, 1 by 2 raised to k plus 1 by 2 raised to k plus 1. Up till here the result is already there with us and that is 1 minus 1 by 2 raised to k, and we have this additional term 1 by 2 raised to k plus 1. Now we all know that a raised to m plus n is a raised to m into a raised to n. So like that, writing this is like writing 2 raised to k into 2 raised to 1. What is the use? The use is that if you could take these two terms together, 1 by 2 raised to k can come common. So let's take that out. 1 minus will stay as it is, but amongst these terms 1 by 2 raised to k is common, so we have taken it out. Here what remains? Nothing is remaining, so 1 is remaining. In the other term, because minus has already come out, one more minus will stay here and the leftover term is 1 by 2. 1 minus half, as we saw before, is half. So you will get 1 minus 1 by 2 raised to k into half when we solve the bracket. So what will happen? We know that in the fraction multiplication, multiply the numerators, multiply the denominators. So 1 into 1 it's 1 and 2 raised to k into 2. That is 2 raised to 1. Just the opposite process of what we did here. A raised to m into a raised to n is a raised to m plus n. So the powers are going to get added up and it is becoming 2 raised to k plus 1, and that's exactly our RHS. So therefore we get this to be equal to the RHS. Like that is how we get LHS to be equal to RHS, and that is how you get P of k plus 1 is true. Then we can conclude that from steps 1 and 2, given mathematical statement is true by principle of mathematical induction. So that is our problem number 9. On the same lines, we are going to proceed for problem number 10. So let's see how that is going to work. Problem number 10 says that it is 1 by 2 into 5 plus 1 by 5 into 8 and so on. The last term is 1 by 3 raised to n minus 1 into 3 raised, it is 1 by 3n minus 1 into 3n plus 2, and here it is n by 6n plus 4. You have got to show that this is equal to n by 6n plus 4, and you have got to know how it's like by what way you are able to show this. Again we are going to take up induction and we are going to show it. So let Pn represent the given mathematical statement. To show that P of 1 is true, what do we have to show? First term from here, 1 by 2 into 5 and 1 by 6 into 1 plus 4. Let's take the LHS. It is 1 by 2 into 5, which is 1 by 10. And what is it up over here? 6 plus 4. So that is again 1 by 10. Like that, you have LHS to be equal to RHS, and therefore P of 1 is true. And then we, in the step 2, we assume P of k is true. So you have 1 by 2 into 5 plus 1 by 5 into 8 and so on. We know we are going to substitute this by k. 3k minus 1 into 3k plus 2 equal to k by 6k plus 4. Now, P of k plus 1 is true. If you have to show, again what do we have to show? 1 by 2 into 5 plus 1 by 5 into 8 plus and so on. 1 by 3k minus 1 into 3k plus 2. Now the kth term is what we need to find. Let's see what it will come. 3k minus 1. That means we have 3 into k plus 1 minus 1. That means it's 3k plus 3 minus 1, which means it's 3k plus 2. So the first term is going to be 3k plus 2. Then let's see what's the next term. 3k plus 2. So 3k plus 1 plus 2. So it's 3k plus 3 plus 2. It's 3k plus 5. Right, there are other ways also, like if you are very carefully observant, you know that this term is repeating here. So like that also you can predict. That is also fair enough. It depends upon your observation. How keenly you are able to observe, you can predict the terms like that. Okay, this is a technical way of doing it. And then once you are a very keen observer, you can write these terms directly. You don't have to support it by steps. So if you can observe well, you can write it then and there itself. So here now it's going to be k plus 1, and 6k plus 4 means 6 times k plus 1 plus 4. So 6k plus 6 plus 4. So it is going to be 6k plus 10. So you've got to show all this. Now how you are going to do all this is, you are going to take the LHS, and LHS is going to be 1 by 2 into 5 plus 1 by 5 into 8 and so on. For the kth term will come. And the kth term is 3k minus 1 into 3k plus 2. Then is your k plus 1th term, and that is 3k plus 2 into 3k plus 5. We know the result till here, so that we are going to substitute. And what is it that is going to come up like? It is going to be k by 6k plus 4. And then you have the last term also. 3k plus 2 into 3k plus 5. So if you are very carefully observant over here, this is if you take 3 out, it is if you take 2 out, then it is 3k plus 2. Very carefully if you observe. So writing 6k plus 4 is like writing 2 times 3k plus 2. Why we are bent upon this? So that you can have this coming out. So in the next expression, 1 by 3k plus 2 will come out. So what remains? K by 2 will remain and 3k plus 5 will remain. Now we can do nothing with this, so we have to equalize the denominators. So what will happen? You will have k multiplied by 3k plus 5, here also multiplied by 3k plus 5, this multiplied by 2, this multiplied by 2, so that you have it equalized. Now what will happen? 1 by 3k plus 2 over here, and what happens over here multiplying? So 3k squared plus 5k plus 2 over 2 by 3k plus 5 when we did all the equalizing. Now what have we got? We have got 3k squared plus 5k plus 2. Now if you have to further solve this, you should be able to get it factorized. So let's see how we can get this factorized. 3k squared plus 5k plus 2. 3 into 2, it's 6. And we know that we can write 6 as when we are writing 6, probably you could write it as, depending on the factors, you can take it as 3 into 2 or 6 into 1. Probably 3 into 2 should be okay. So 3 into 2. So it is like 3k squared plus 3k plus 2k plus 2. Fair enough. So what will come? And 2 times k plus 1. So we are left with k plus 1, 3k plus 2. That's how this is getting factorized. So you have 1 by 2 into 3k plus 5 and 3k plus 2 in the denominator, and in the numerator we have factorized the numerator as k plus 1 times 3k plus 2. What's the advantage? this 3k plus 2 is cancelling off, and in the denominator, in the RHS, you are getting k plus 1 times 2 into 3k plus 5. You could also open it up, you will get the same thing. So that will become equal to the RHS. That's how you have, if you open it up, you will get whatever you require. So that's how LHS becomes equal to RHS, and that is how we are getting the required result. It's not 9th, it's a 10th problem. Yeah. So that is our problem 9 and 10. The remaining problem is in the next video. Thank you.